Welcome to CXOTalk, episode 854. I'm Michael Krigsman, and we're taking a peek inside Cognizant's Advanced AI Lab with Babak Hodjat, the company's CTO for AI.
I am the CTO AI for Cognizant. I run our Advanced AI R&D lab here in San Francisco, where I am right now, where we do core AI research, as well as feeding into our flagship Neuro AI platform, which helps our clients with AI-based decision-making.
You were one of the inventors of the underlying natural language NLP processing techniques that are used in Siri. Maybe tell us about that. And is there a link between that research and what you're doing today?
I was actually working on my PhD on a distributed AI-based technology called multi-agent-based systems. I was amazed by how powerful these systems can be. While AI itself was still kind of in its infancy, did well on toy problems, but didn't quite scale. When you actually put multiple AIs together into a system, they did quite well. And a friend of mine, through a sort of a misunderstanding, challenged me to make use of that same technology to understand people commanding and controlling things like the TV set to change a channel or what have you. And at first I thought that was too complex a problem to tackle for AI. Natural language was the first non-numerical application of computers, but it had never been quite solved. It's very, very difficult due to the ambiguities of language and how complex language is. But then he challenged me and I worked on it, and it turned out that for the domain of command and control, using a multi-agent based architecture actually makes a difference. And it was a big departure from the traditional way of doing natural language, processing grammar, doing a parsing, then looking at the semantics, then maybe looking at the context, and all the while being very language centric. So if you did English, then moving to Japanese would be a completely different ballgame. And so it opened up the door to many possibilities in that domain of command and control, and ultimately led to being able to create the natural language interaction core that ended up being Siri. The relationship to today, in some ways, it's very analogous, because today we're back into a world where we see how scaling AI and moving it into businesses and various different applications in a multi-agent manner is preferred than a centralized single system doing everything. So agenthood and multi-agent systems are enjoying a big resurgence right now. It's different in the motivation. Back then, the AI was really limited. And so to empower it, you kind of reduce the domain of application, called it an agent, and said, here's what you go do, in conjunction with other agents with reduced domains that then they would interact and solve a problem over that community of agents. Today, a large language model, which is the core of agents as we define them today, are very, very powerful, and they can be many different things at the same time. So you have to tell them what to be. So it's kind of the inverse. They can be many, many different things, but you have to reduce that domain to tell them, here's what your set of responsibilities are, and here are the requirements for what we want you to do in this particular context. And then we call it an agent. So coming at it from a very different angle, but ending up more or less in the same place as what we did back 25 years ago.
When we talk about agents, or the term agentic AI is now becoming more and more commonplace, very ridden with hype. You use the term multi-agent systems. Can you elaborate on that term?
We all are familiar with large language models and generative AI models. what those models do is they take input and they generate output. So the keyword is generate. Take input, that input might be text, images, video, all of the above, and the output as well could be different modalities. What an agent, the distinction between that model and an agent is the agent does things. So it has a toolbox and it can actually affect its environment and observe the effects of that change or using those tools. Let me give you an example. You can go to ChatGPT and say, write me code, for example, to, I don't know, make some calls to the Amazon API. Okay, it'll write you that code. It will just generate the code. It will not run it. It will just generate it. It's so good that that code might actually work. If it's not complex enough, then you might be able to rely and trust that code. The distinction, though, is that if you had an agent, it would be able to actually run that code, maybe in a container, make the calls to Amazon, check to see whether its unit tests are passing, and then modify the code if the code was broken before it came back to you and says, here's the code. So that's one agent distinction between an agent and a large language model. Now we're talking about multi-agent systems, which means that we have different functions in some sort of organization. In coding, it might be that we have a project manager, we have a programmer, we have someone that writes unit tests, we have a back-end coder versus a front-end coder, we might have a UX designer versus a UI designer, and we might actually have a Kanban board where we're actually posting tickets and closing tickets for the coding. So right there, I listed a number of different tasks and different responsibilities, and that's how, as human coders, we organize ourselves. Now, we have a choice. We could either rely on a very powerful, large model or single agent, maybe even, and say, go do all of those. It's very difficult to set that up. Currently, we have limitations on the context. The complexity of what we're expecting the system to do is very high, and observing how various different elements of what we're asking it to do is difficult. For us to set a system like that up, we already are thinking in a very modular way anyway. So mapping that modular thinking, that structured thinking, to the way we set up a team to produce the more complex, larger, maybe software package that we want the team to create, just simply makes sense. And that mapping is basically by creating multiple agents, each agent being responsible for a part of this whole. And for example, the product manager, project manager, the UI, UX designer, each becomes their own agent. In the context of the agent, we tell it, here's your job description, here's what you need to do, here's what to expect to get from this other agent, and here's what to return to it. And then we set it off to operate. There's a number of very interesting properties, not the least the fact that we can think of ourselves as agents in this structure as well, and define the human role within that structure too. Unlike, for example, treating this whole thing as this black box single agent that we ask it to do something and then we expect it to return something, we're not anywhere in that loop. So that is one of the important reasons why looking at software in general and even organizations as multi-agent systems makes a lot of sense right now.
So are you attempting to then model the construction of an organization in software using these multiple agents, each of which is designated to accomplish a particular task? Is that the basic goal here?
That's great. You've read my mind. That's exactly right. So it goes beyond software. So we know, so for example, from the one side, we can look at software. Software is already inherently modular. We've had this whole object-oriented approach that's been the underpinning of a lot of software, principles for quite a while. And objects are just a tiny little step away from agents. So you can think of software itself as being this modular system that can now be represented by agents, and it has some very, very interesting properties if there are. So we can talk about that. That's really interesting. But this goes beyond just software. We can look at an organization where the responsibilities are in these nodes. Could be human, could be software, could be a mix of both that are running this organization. As long as we can actually list those responsibilities and tasks and job descriptions and what to expect coming in, what to expect to leave, what to expect or task the agent to expect from some other agent to deliver to them. If we can actually define these relationships, then we can actually attempt agentifying an organization that's not necessarily a piece of software, and it has huge implications. So yeah, that's an area of interest to me. What are the implications? How do you do this in a human-centric or human-augmented way? How do you guarantee that a system like that actually works? What are the properties you gain? Because running like thinking of everything as agents has its costs too, right? You're running large language models, which are the brain of each agent. So you are actually tasking, you're still running large language models for every step of this organization. So depending on the throughput, you are paying good money to operate this thing. So on the other hand, you're getting robustness. You can get it's future proof. There are a lot of very interesting properties that you're getting as well.
It sounds like you are constructing a robot army that encapsulate large language models to accomplish whatever goal you want. You're nodding your head. Okay, so then we know that LLMs hallucinate, they make shit up. And so, how do you prevent your army or members of your army from going rogue?
Large language models confabulate, yeah, or commonly known as hallucinate. They make stuff up because they're generative. They're not trained to be truthful. They're trained to pass muster with their output. That is a real problem. And it's another reason for us to agentify, because when you actually reduce the scope and domain and make it very clear what you expect, you reduce the hallucination. So that's one aspect. The other aspect of this is we need to make sure that we have instrumentation in the agent that tells us when we can trust it and when we should, verify. And there is some very interesting recent research, some of it coming out of our lab here, that measures uncertainty on large language models. It's very amazing. So given a context, again, that context is important. Therefore, this is something that can be handled within an agent scope, not in a general scope. But given a context for a certain input and an output that we get from the agent, how much can we trust that output? And if now we have a measure of that, and based on that measure, setting a threshold, we can say, hey, right here, what this agent did, I can't trust it as much, so I need a human to verify it. So another reason to actually look at these systems from an agentic perspective versus, one size fits all, LLM that does everything.
Subscribe to our newsletter and subscribe to our YouTube channel. Check out CXOTalk.com. We have really phenomenal shows that are coming up with amazing people between now and the end of the year. So check it out. Join us. Greg Walters makes a very interesting point. He said, won't an army of agents actually cut down on the probability of mass hallucinations because of self-checking and self-healing? And is that possible?
Absolutely. The fact is that you can even task some of these agents with the responsibility to check other agents for things like hallucinations and such. So, and if I'm an agent in a pipeline of agents working together, and the response I get from another agent is iffy, or is not really what I was expecting, I can also go back to it and say, hey, try again, or, refine my inquiry back to that agent. So even automatically between the agents, we can manage a lot of this hallucination. Now, having said this, we we are faced with a new reality with large language models being the basis for a lot of what we do these days. And that is that we cannot guarantee that these systems would never hallucinate. So if anybody goes out there and for marketing reasons or whatever tells you they can guarantee there's no hallucination, take it with a grain of salt. That itself might be hallucination. Anyway, that's not possible, but we can gauge and measure it. We can reduce it. And the other thing that we need to also remember is that we're faced with that army is a set of black box agents. So while we do have tools to try to pry into their thinking, their logic, their reasoning, at its core, these systems are deep learning neural networks that are very, very large and black boxes. It's very difficult for us to know exactly how they're thinking. And now, the good news is we've been dealing since, I would say, industrialization, we've been dealing with these sorts of systems. It's just that they've been human driven. Humans are black boxes, and we really can't read another person's mind. And we do give them, we give them a set of responsibilities in a larger organization. We know how to do that. And so the good news here is that we're not faced with this really unknown new era of multi-agenthood. We can borrow from, all that we've learned through industrialization and setting up these organizations and bring those in to make sure that agentification, operates predictably and productively, and with high quality. There's one other thing I wanted to mention before we forget, which is one of the things that's amazing in this new era of multi-agenthood. Back when I was working on the pre-Siri days, we had to define the language between the agents. It was a non-ambiguous set of instructions that these agents needed to issue between each other in order to communicate. We don't have to do that now. In fact, the native language of a large language model is natural language. It's English. And what does that give us? There's a reason why language evolved in humans the way it did. It's very, very expressive, and it allows us to express intent. So now you have a organization basically where the connection between these nodes, let's say if we had software, the connection between the nodes is expressing intent versus making specific calls. And this makes it robust and future-proof. You can replace various elements, for example, in your software. One of the examples I use is, I used to work at Sybase many years ago, and we had databases. They were not the state-of-the-art databases. We had lost the database wars back then. But these databases were the standard in Wall Street for like 15, 20 years. They were legacy. The reason why they were standard was because it was very, very difficult to yank them out and upgrade them or change them because they were like ingrained into the software, and probably the people who integrated them had long left. And so, that is a thing of the past now. That robustness that the connection between software nodes now, which are now agent nodes, gives us, which is intent-based and natural language-based, allows us to replace, upgrade without caring about that integration as much, because the connection between the intent and the call into the specific API is handled by the large language model now. So that gives us a lot of flexibility just on a software side, and is another, I think, for someone who has a software engineering background, I think that's a really interesting property of multi-agenthood too.
You said that we have been dealing with humans who are making decisions through organizations from the beginning of organizations. However, if we look at it from an ethical perspective, one fundamental difference is with humans, of course, we're the sum of everything that we know, and we could call that data. And of course, we have our biases and so forth. However, when it comes to data driven decision making, I don't think we can be quite so easygoing about potential biases that live in the data. Maybe talk about that aspect of it.
There may and certainly are biases, even in our very general purpose large language models. And we need to control for them for sure. So that's one big major risk. There's also data inherent in the data that we've collected and we're operating on. So I, one thing first, before I address the question directly, one thing I wanted to mention was the fact that um, if we just create an organization that's only large language models operating based on their beliefs and their training, then I think we've done a disservice. That's not where we want to go. If an organization already has data that they've collected and historical data around the decisions that they've made and their operations and so forth, that data is invaluable. And so we have to task our agents to literally defer to that data and perhaps even use what is now called traditional, as of 2 years ago, ML models and analytical models. So we have the agent, which is a large language model based agent, operating a machine learning based or analytics based data driven model based on that data. And it's making its decisions. That is much, much more reliable than a single large language model based agent that's just doing guesswork based on its reasoning and opening us up to a lot of bias that is inherent from all the data in the world that it's ingested to be trained. So that is super important. It still doesn't take away our responsibility on the data itself that we've collected that might inherently be bias too. So the principles of responsible AI, which we had to care about even before the advent of large language models, still carry forward and are even more important right now for us to build into the framework that we use in creating, in agentifying systems. It kind of, let's be realistic, in the past couple of years, that has taken a little bit of a back seat. And it's scary because, we've been distracted by the power of large language models and generative AI. And we're like, wow, this thing is so useful. I'm going to go all in. And I'll talk about the responsible AI part of it. And it's become like an afterthought. And I think that's risky. And I think that that's one of the things that we are really emphasizing in the steps that we recommend as far as how do you agentify. And built into it is a framework that is domain specific and has human centricity as well as responsible AI and ethics and governance considerations built into it. So it's important, and there's no simple general statement that I can put out there and say, do this and then you're responsible. It's very domain specific, for sure.
We have a very interesting question from LinkedIn, and this is from Avi Singh Malhotra. And he says, how do you envision the balance between human capital and agentic AI workers evolving over the next decade? And what strategic shifts should organizations make to fully capitalize on this workforce transformation while maintaining a competitive edge?
We did a survey, we did a research along with Oxford Economics on the impact of generative AI on jobs. And the methodology was really interesting. So we basically took all the jobs in the US job report. And we broke each job into its constituent tasks. And then we said, okay, here's where generative AI is today, and here's where we think it's going to be in 5, 6, 7, 8 years from now. Which one of these tasks is it going to be disrupting? And it's different depending on the job. And amazingly enough, it impacts 90% of jobs, regardless, right? So this is the reality. And the way to look at it is to actually redefine and help move the job description so that the focus is on the part of that set of tasks that the humans are responsible for and will be the exclusive domain of humans. And yes, to endorse and bring in generative AI and agentic AI to cover the rest and to help those jobs. This report also included those jobs that would have a harder time keeping up, to help those folks to reskill and upskill and come in. There are cultural reasons why humans, at least in the foreseeable future, will have an important central role in any agentic system that we build. There's cultural reasons, for sure. There are going to be, as an offshoot of those cultural reasons, there are going to be preferences built in. Like when you look at arts, for example, someone asked me, like, arts now, you can produce many arts, they're satisfying to a lot of people, and it's all generated by machines. What is the future of arts? And we're at that transition point, like we were with photography. Like people thought that painting is just going to die because photography, you can just click and you get a photo, and there's so much of it now. And photography was able to redefine itself. So there is a little bit of that. There's also the value that we ascribe to just the human being part of the role. Like if this is created by a human versus this is created by a machine, the value of that for a human society is going to be different. And that value is going to ensure that humans have a role there. So there's a lot to unpack here. And of course, I'm not a sociologist, so it's a little bit outside of my comfort zone to opine there. But suffice it to say that there are many reasons why, at least in the foreseeable future, humans will have a very important role. And I think going back to the Oxford study that we did, I think one of the first things we need to do with an organization is list the jobs, list the tasks that are going to be disrupted. There's going to be time. Yes, this disruption is unfolding very quickly, but we will have the time to be able to upskill, reskill. And as we agentify, trust me, I think we're going to, as humans, be much busier sort of operating these agents and agent-based systems versus sitting back and not having much to do.
Over time, social expectations and cultural norms also change to incorporate the outcomes that technology gives us. What used to be science fiction and impossible, today we accept as a natural course of events, such as getting on an airplane.
That's exactly right. There may be a future that if we try to envision right now, we would be very, very, very uncomfortable, including those of us who are working in AI. Just picturing it, but yes, societies change, value systems change, culture changes, but we don't have to worry about that right now.
Elizabeth Shaw on Twitter says, can you repeat your comments regarding Gen AI versus Agentic AI and the difference in their focus?
A generative model generates stuff. That's what it does. So you give it inputs and it generates stuff. An agent has the facility not just to generate, but then to actuate. So that actuation, that doing something versus generating something, is the distinction between an agent and a generative model. So it's as if you have this little sandbox that you give the model and you say, hey, like if you're writing code, run the code too, and, check the output and maybe modify it if it's broken before you respond to me. So in writing code, that would be an example. But it doesn't have to be a sandbox. It might be actually operating something like make this call. Somebody just submitted a request for new software. If you get this request and get all the information and verify that they're who they are, here's the API for verifying them. And here's the API for, I don't know, opening a ServiceNow ticket to get them the software. Do it. Like that's what the agent is going to do. A purely generative system is not going to do that unless you give it the facilities to be able to operate, call APIs, and do stuff. That's the main distinction.
We have another question from LinkedIn from Greg Walters, who says, years ago, or a couple of years ago, he wrote about AI bringing about the end of the C-suite, which on the surface seems like kind of a silly question. But to what extent will AI take jobs from senior business leaders? Because after all, any half decent LLM knows more than any of us.
When we look at an organization, as we go up the organization, the decisions are more and more consequential and less data driven in some ways. And the focus has always been, let's automate and let's verify and let's improve and optimize decision making on these leaf nodes and somehow pay a lot of money to the top nodes. I mean, I'm saying that as someone who's a C-suite as well, so I guess I'm speaking against myself there. But the fact is that now we have the capacity to help with that level of decision making as well. Now, when I talk about AI decision making, usually it's misunderstood as, oh, we're always doing that. Like AI helps us, gives us the insights, and then we use the insights to make decisions. And so it's almost taken as, humans have this exclusive domain of making decisions. And that's what I want to dispel. We're not very good at making decisions. We have to face it. We usually, we're very emotional. We're very subject to the latest thing that just happened or the latest news that we got. So recency of something affects how we make our decisions. We're myopically focused on a single outcome or objective at a time, whereas most decision making is a balance of more than one outcome. And we don't really have the capacity to look at a lot of data to make our decisions. So often, we walk in and have a gut sense of what needs to be done that is very skewed and biased and often could be irrational, and we make the decision. And we're paid for taking the risk. Because when you think about it, if we're not very good at making decisions, but the decisions that we have to make are very, very consequential, we're taking a lot of risk taking them. And so the value of us now is in taking the risk versus actually making quality decisions. And I think AI systems can be very good at augmenting us in making decisions. They can already look at many more factors than we can look at any given point in time. And they can optimize against more than one outcome at the same time. They can optimize against, I want to improve revenue while reducing cost, while improving sustainability, while reducing bias. It's like right there, there's 4 different KPI that I just mentioned, and I have to have all 4 in mind before I make a consequential decision. And so I think it's really important for us to start bringing AI into our decision making. And there is a very good methodology for how you can capture the historical decisions that you've made up until now, bring in the data that is consequential to the decision making, and have an AI tell you, in this context, here's what I think you should do. Here's what is going to happen if you do this. Here's how certain I am in my prediction of the consequence of your action. And here's an explanation as to why I think you should be doing this. And also, If you want to do something else, let me know, and I'll try to predict what the consequence of that alternative is going to be like. We see that all the time.
I find myself coming down, surprisingly, on the side of Greg Walters about the replacement. And let me tell you why, based on what you just said. There is an entire field of study that we can call commonly the wisdom of the crowds. And LLMs represent kind of the ultimate wisdom of crowds because LLMs, if they're big enough, they have all information. And so if we have to make a judgment, doesn't it make sense to call on that LLM to make the decision because the LLM can sum up human experience, human history, human knowledge, human actions, and human outcomes to guide us to the wisdom of the crowds that's actually the best decision. And so from that standpoint, why do we need so many senior execs?
No, I disagree with that for a number of reasons. One is the LLM is fixed in time. It's only trained up until a certain point, and the PT and GPT stands for pre-trained. These foundational models don't learn after they're trained, so don't rely on an LLM alone for that decision making. The second thing is, yes, it knows a lot of stuff. The wisdom of the crowd is in there, and maybe you can rely on it for some of its reasoning that's derived from that wisdom of the crowd, but it's the wisdom of the crowd. It knows nothing about your specific context. The here and now of you and the decision you need to make and the consequences of that decision. So don't rely on that. You should certainly consult it, and in many cases it will give you some good advice, but don't rely on that alone. And thirdly is the fact that if you do have data, and you can have part of that decision making rely on the historical data of decisions you've made in the past and the consequences of those decisions, you should use that data and specific ML and analytic models on that data. For example, if you have a digital twin or an ML-based digital twin of the subject of decision making, you can actually optimize against that digital twin and come up with a much better decision strategy than any LLM could give you. Let me give you an example. Like, let's say I have this, I don't know, refinery, right? And I need to make some adjustments to the refinery process to make it give me more throughput, but reduce its emissions, right? Right there, it breaks down. Like, would I go and ask an LLM what to do? Maybe at a high level, it'll give me some tips what to look into. It knows nothing about my specific refinery and the state I'm in right now and the price of oil today and all that kind of stuff. So, okay, I have to give it all that information. Then it doesn't really know much about the alternatives that are available to me in this particular refinery, the changes that I can make. There are probably many combinations of changes I can make that is unknown to the large language model. The flip side is I have a lot of data about the refinery, and maybe I have a simulation of the refinery as well. I'm putting an ML model of the refinery and maybe ensembling that with a simulation of the refinery would give me this digital twin that I can optimize against. And that optimization is which knobs and levers to pull and turn in order to get the best of the multi-objective optimization that I need to make. I would go with that any day over an LLM alone based system. And so I think, yes, for some cases, an LLM might be a good sounding board, but in many complex, important decisions that we want to make, we have to create these agent-based systems that have these other facilities and tools at their disposal.
Wilson Suarez has a question that I think will lead us into the topic of evolutionary computation, which is another area of focus for you and for the Advanced AI Lab. And Wilson Suarez's question is this: What role do emotions play in a world where humans don't make good decisions and AI is impacting various scenarios?
Emotions, I think, are very context and cultural specific, and they are an abstraction on a set of um, basically sensations, like a sequence of sensations that we have, and they're typically not the same between two cultures. Um, so making emotions central to our decision making is more of a sort of consequence of how we think and how that affects us versus, you know, a some sort of sequence of steps or analytical approach to decision making. So I don't think of emotions as this like coming from a different source and kind of informing decision making versus analytics or data driven decision making. So let's set that aside for a moment. Emotions. I would say that at least the sequence of sensations may have been evolved. Just I'm trying to build that a bridge into evolutionary computation here. Um, but there is an interesting other aspect that might be missing, which is creativity. Um, and creativity is interesting because the sum total of humanity's knowledge captured mainly in text that informs a large language model is just that. It might not capture very new stuff that we might encounter or need in very new situations. And so while in an interpolative way, a large language model might be able or is able to actually create net new things that we've never seen before and are interesting. But on a go forward basis, we might need to borrow from how evolution adapts in nature to new situations and what we call creativity. And there's a lot of very interesting work right now on how do you rapidly, um, uh, search for new solutions, creative solutions for new situations by borrowing from population-based approaches. What does that mean? That means rather than in the case of a large language model or a deep network, you have one model. It's the same model, and it was trained one time. In the case of an evolutionary computation methodology, you have many variations of models that operate differently, and many of them, are useless. They're too creative for their own good. But some of them are useful and different enough that you want to keep them around and maybe mix some of their traits with some of the other models. And through multiple generations of doing that, you end up with new and interesting and adaptive systems. So that's evolution and evolutionary computation. Up until now, evolution has been primarily done through methods that many of your listeners might have been familiar with genetic algorithms. So we have one model, or we have two parent models. Both are kind of fit for their environment. We borrow some of this and some of that, and maybe tweak something randomly. So we have a crossover and we have a mutation, create a new model, and then verify if that model is interesting or not. And sometimes it is more interesting and better than the two parents, and we keep it around. Um, Recently, though, what we've observed is you can actually pull large language models into this algorithm. And it's as if you have a human kind of with human reasoning looking at the two parents and going, wow, this trait here is interesting and that trait there is interesting. And through my reasoning, I'm going to use those rather than randomly selecting. You're kind of being very mindful about how you generate that child model. And that you still need a healthy dose of randomness and so forth, but it has enriched evolutionary computation in some ways. And so there's this give and take between, evolutionary computation bringing in more creativity into the state-of-the-art AI, which is large language models, but at the same time, large language modeling also kind of bringing in this reasoning into how we do evolutionary computation. Let me just give you one very interesting example again out of our lab, which is we fed an evolutionary-based system that was augmented with large language models. The papers published in a conference, we took ICML, but you could take any conference in any domain. We fed it the history of papers, title, abstract of these papers, and some summary of the body. And we had the system map it as far as how creative these papers are. So let's imagine a two-dimensional map with these papers on it, and you will very quickly see clusters of papers. So someone came up with a really cool idea, and then other people are kind of building on that. So there's a cluster of papers here and a cluster of papers there. And every once in a while, you see a new paper somewhere out in the wild that is totally out there. And it brings a very novel, interesting idea. And then a cluster starts building around that through time. So every year as we do this conference. So one of the interesting things that you can do now is predict what are the papers that are going to come out next year. So at ICML 2025, what are the papers and what clusters are going to grow, what clusters are going to shrink, and in what areas in that, sort of space of possible papers are you going to get very interesting papers. And what's even more interesting is that you can task the large language model to guess at what the title of those net new papers are going to be and what the abstract of those papers are going to be. So that also kind of gives you this mix of a population-based approach and evolutionary sort of techniques and large language models, allowing us to almost brainstorm around, a topic, a domain, and predict what might be interesting in that domain.
Why does this approach work particularly well for problems, for example, such as conversion rate optimization on a website or robots walking?
Conversion rate is very interesting. You have a built-in sort of measure. You have a website, it's configured in a certain way, and you know very quickly whether that your website is working or not. Because if people click and buy or click or spend time on that, that's like positive reinforcement for you. And so if you actually modify that page, you very quickly know whether or not you made it better or made it worse. In other words, it's fitter or less fit. So that gives you the possibility. I mean, we hear a lot about A/B testing. Like let's divert a percentage of our users to this new page that we've just designed to see whether it does better or not. And if it's better, we'll take that. Now, the problem with that is you only have two pages at any given time. You have your incumbent page and you have the new page. And so it doesn't give you a lot of leeway to make improvements, try new improvements, and also keep up with a changing world, because things might change and your user base might have different preferences. So one thing you can do is you can actually create variations to your current successful page and redirect to that population of possible pages, redirect some of your user base. And depending on how well the pages do, you direct more population, more users to that page and less to the others. And the ones that are doing better, you can mix. So there might be elements in one page, your one web page, and elements in the other web page that are doing better, and you can mix them. And perhaps the resulting new page is going to be even more interesting. So it's almost like running an evolutionary process live, with humans basically assessing, how well you're doing, because they're the ultimate subject of whether your conversion goes up or down. So works very, very well, improves conversions. In fact, the company I was at before joining Cognizant. Sentient has a company sort of branched out of that called Evolve.ai that does exactly that. And they were able to show not only that they can actually improve conversion rates significantly, but they can also leave this system kind of running live. And when they hit certain times of the year or certain events happen where the preferences of their users change, the system also adapts to that. So it's almost like the design of the page changes and morphs depending on the preferences of the users.
What does this have to do then with robots walking? And on your lab's website, you have a demo showing the use of these algorithms. And by the way, as you're discussing this, we have a question from Elizabeth Shaw on Twitter who's asking, what are evolutionary algorithms and what are the practical use cases beyond genetics?
Let's say you want to teach a robot to walk, and it's encountering unknown terrain all the time, but there are some laws of physics that initially it doesn't know about. So one of the things you could do is you could have it like an agent that we were talking about, interact with its environment, like try various different things out, and not try to walk initially, but try to just sense its environment and the physics of its environment, and then build a model of that environment, and then train in that model. It's much less costly. If you fall and break your neck in a model, you're not really breaking your neck. In the real physical world, you might be breaking the neck of that robot, and that's costly. And so that's what we were trying to illustrate there, is that there is a version of evolutionary computation called evolutionary surrogate assisted prescriptions, which calls for that. It basically says, look, you should always, and at any given point in time, create a model of your environment. So remember how the agent is actually operating, doing stuff in its environment. This system says, create a model of that environment. So basically track the reactions of that environment to what you do. And based on that track, create a model, like train a model. And then instead of trying things out in the real world all the time, try things out against the model. That's cheaper. And you can optimize against that model in your head and then start walking. So when you look at that walking robot, at first, we have ways to actually visualize what its model is telling it. And at first, the environment that the model is picturing looks like very hallucinatory. Looks like, trees are levitating, or the sky is sometimes on the ground, or whatever, right? Because it really hasn't had a lot of experience trying out what's out there, right? But as it's trying to learn how to walk, it's also trying to learn the physics of its environment. And gradually you're seeing the environment kind of stabilize into the environment that we're seeing from the outside. Because every once in a while, it's trying stuff that it knows to work in its model against the real world. And based on that feedback, it's adjusting the model itself. And what's interesting is that it's actually solving a harder problem, because that world that it has in its head can be pretty squished. Like, if a tree levitates and you need to walk around it, yeah, that's much harder than a tree that's stationary. So if you learn how to walk in the world where trees levitate, you're definitely going to be able to walk in a world where trees are stationary. So that's one of the interesting properties of this approach, is that it makes it much more robust as well, and future proof. And you can change the environment suddenly on the system and very quickly adjusts its model in its head, and it's able to operate there. So there is an evolutionary technique that allows us to do that quite rapidly, and it's very effective and cost effective as well.
Can you provide any advice, thoughts on enterprise AI adoption and the hurdles organizations face? And just really fast, please.
Businesses have gone for the low risk and obvious use cases of generative AI. Without knowing, I think they are already agentifying because they've gone in and said, hey, I want something like ChatGPT, but I want it to actually work against my proprietary data. So they've created these agents that can, for example, retrieve some proprietary data for them. And then, maybe they have this other app and they want an agent to operate that app. So they've created these single agents in isolation right now. And I think the logical, obvious next step is have these agents talk to each other, like link them to each other so that you don't have to force the user to choose who to talk to. You can talk to one and they kind of sort it out between them. So I feel like that's where we're going, but don't let it happen to you organically. You need to take steps to make this human-centric, to make it responsible. And also, I think it has the potential to be disruptive. So you need to be able to think ahead as to what this will do to your workforce, what this will do to your processes. And so, yeah, I'm an optimist. I think there's a very, very bright future with agent-based enterprises coming our way. I just think that we need to go at it with open eyes. Yeah.
Babak Hodjat, CTO for AI at Cognizant. You have given us a lot to think about, and thank you so much for taking your time to be with us today. I really am grateful to you.
Of course, enjoyed it a lot and some very good questions. Thank you.
Everybody listening, thank you for watching. Before you go, subscribe to our newsletter and subscribe to our YouTube channel. Check out CXOTalk.com. We have really phenomenal shows that are coming up with amazing people between now and the end of the year. So check it out. Join us. A huge thanks again to Babak for being with us. And everybody, I hope you have a great day and we will see you soon.